Hello everyone, welcome to your 11.4 lesson on normal distributions. So we were introduced to that in our 11.3 lesson, so now we're going to focus on strictly normal distributions and learn more about those. Our learning target for this lesson, we will be able to understand where a data value falls in relation to other values in a normal distribution. We'll be able to fit a normal distribution to data. We will compare and evaluate data values using z-scores, and then we'll use technology to calculate the area under the standard normal distribution curve. We're actually not going to do that last one. All right, so we have this thing called the empirical rule in statistics. The normal distribution has a special property called the empirical rule. The approximate percentage of data values falling in any interval of the range of the data can be determined using just the mean and the standard deviation. So what we have here is a normal curve. It is symmetrical. The mean is going to be at the center of your normal curve. And they said right here for a population, the mean is denoted by this Greek symbol is called mu, mu. And the standard deviation by this guy, which is a sigma. So what we notice in the normal curve is that our mean is at the center of it because it's symmetrical. If your data distribution is symmetrical, the mean will be in the middle. And then what we're doing is we are counting by standard deviations. So this first one, I feel like they should have written in here, should be mu plus 1 standard deviation. And on this side where that blue line is should be mu minus a standard deviation. Basically your mean plus a standard deviation and your mean minus a standard deviation. So here's your mean, 1 standard deviation to the right, 1 standard deviation to the left. 68% of the data is going to fall within that range. If you go 2 standard deviations out, again, we're staying symmetrical. Here's the mean. Go 2 standard deviations out. So here's your mean plus 2 standard deviations. Or if you go 2 standard deviations in the other way, 1, 2, here's your mean minus 2 standard deviations. So from here to here, it's that 68% in the middle, but then it's going to be even more of the data. That is going to be 95% of the total data. And then the third interval we look at is what if you go 1, 2, and they didn't write it, so let's write that in. This one right there is your mean plus 3 standard deviations. And on the other side, right here, is the mean minus 3 standard deviations. So what percentage of the data lies within this range from if you're 3 standard deviations below to 3 standard deviations above? That's the 95% in the middle plus some more. So that percentage is 99.7%. So almost all of the data is going to fall within 3 standard deviations of the mean. Remember, a standard deviation is just how much on average does your data relate to the mean? How far away is it from the mean? Okay, so let's just fill in more formally. How far from the mean does a value in a normal distribution fall? So about 68% of the data falls within 1 standard deviation. About 95% of all values fall within 2 standard deviations. And then about 99.7% of all values fall within 3 standard deviations. And when we say that, like within 1 standard deviation or within 2, we're talking within 1 standard deviation from the mean. So how close is it to the mean? And then just let's make sure we are understanding all of this, like what this whole lesson, what we're going to be learning and working on, only applies to normal distributions. So that's pretty important. If we had a distribution that was not normal, let's say it was skewed right or skewed left, we wouldn't apply any of what we're learning right now.